Hello geometers and general seekers of truth. Welcome to the video lesson on rotating some points on the coordinate plane around some other point that's not the origin. Okay? Not the origin. So if we rotate 90 around the origin, if we pretend like it was for the origin, then the rule we've talked about in class is quite simple. AB will become negative BA. But this only applies when we're rotating around the origin. You know, what are we supposed to do when it's not around the origin? Well, I'm just going to start out just by graphing this, and then we can discuss different methods and ideas when we have to deal with something that isn't around the origin. Okay, so let's see. My first point is 3, 2. So 1, 2, 3, 1, 2. My second point is 1, negative 4. So I guess I'll call this A. Well, let's not name anything yet. It's 3, 2, negative 1, no, positive 1, negative 4, 1, 2, 3, 4. And then negative 3, 1, 2, 3, 1, 2, 3, 4, 5. So I have that there using my straight edge. You can get this pretty decent looking picture here. Okay. And oh, I forgot to mention that my scale is 1 to 1. Okay. Remember to always include your scale, otherwise your graph is meaningless. Okay, but now the point of rotation is centered at 1, 3. So 1, 2, 3. So we're going to take this point here, we'll take this picture and spin it 90 degrees around this particular point. Now, many of you may try to quote-unquote eyeball it, and you might try to see, oh, where does it go, and just start putting dots where you think it belongs. And I think for this example, that might work. But the minute that you get decimals, the minute you get fractions, you get anything besides really nice numbers, then the process sort of falls apart. So we want to find a more general way to solve this problem. Okay? And again, we have this wonderful rule for rotating around the origin, 90 degrees around the origin. That's such a nice rule, but we don't actually have an origin here to rotate around. We're stuck with this purple point. Okay? So, well, we're going to apply a very beautiful technique, which is to pretend like this purple point here is the origin. Okay? So treat 1, 3 as the origin. Okay? And you might think, oh, well, what's going on here? You know, you're changing the problem on me. Well, yes, I'm changing the problem a little bit, but I assure you that this is all mathematically solid, because one of the things that I'm going to do here is I'm going to change the problem, but when I'm done, I'm going to convert it back to the original. And so let's think about it this way. If the origin used to be where it was before, I think this was our original image, okay? And if I change the origin, what I'm essentially doing is taking this entire picture and shifting it 1 to the left and 3 down. Okay? In other words, I'm doing the exact opposite of this particular point. Okay? So we're going to shift everything -1 and -3. Okay? So all of the points are going to get shifted down to -1, -3, or -1 to the left, 1 unit to the left and 3 units down. And this is going to be my new picture. Okay. Now this is only a temporary solution because in the end I have to convert everything back. And so what are my new coordinates now? Well, you can see from the graph here that this point over here is now negative 1, 2, 3, 4, and up 2. And this point here is 1, 2, and then down 1. And this point here is at 0, 1, 2, 3, 4, 5, 6, 7. So 0, negative 7. Okay, so I'm going to kind of show you here what I've done on my paper. So we start out by using this method, and what we're going to do is treat 1, 3 as the origin by shifting 1 to the left and down 3. So my image matrix now becomes just subtracting 1 from all the numbers on the top. 2, 0, negative 4. And then subtracting 3 from all these numbers down here. Negative 1, negative 7, and positive 2. So 2, negative 1. Let's go back to here. 2, negative 1 is this point. Right? 0, negative 7 is this point down here. And then, let's see, 2, negative 4, 2 is this point here. And now, because this purple point is the origin, I can apply this really beautiful rule AB to negative BA. Okay. And remember, the rule here is pretty straightforward. We swap the top and the bottom rows, in other words, swap the x and the y values. So I get negative 1, negative 7, positive 2, 2, 0, negative 4. And then we multiply the top row by negative 1, so all the negatives become positives, and this becomes a negative. And I'll show you how this lines up here on my graph. So 1, 2. So I guess I should name these points. We should name these original ones A, B, and C. So in my picture, 2, negative 1, this point right here, becomes positive 1, 2. This point here, 0, negative 7, becomes 7, 0. And then this, so this is A, this is B, this is A prime, this is B prime, and this over here is C, and the new one is going to be 4, no, it's going to be negative 2, 4. So this up here is C prime. Okay, so this picture gets quite complicated. Ooh, I think I made a mistake here. This point should be negative 2, negative 4. So C prime shouldn't be there. C prime should be down here. Negative 2, 1, 2, 3, 4. Negative 4 right here. This is where C prime really belongs. Okay, and I'm not going to connect the purple dots yet because it's still pretty messy. So now the rotation is complete. Okay, the rotation is complete. But everything is in terms of our new origin, so we need to convert it back. So we need to take all of these points here and then just move it all back to the way that it was before. Okay. And then we can calculate our we can figure out what these coordinates are in terms of the original origin. That sounds kind of weird saying the original origin, but that's exactly what it is. But let's look what I'm doing here, right? So before, to move our center of rotation to the origin, I moved it 1 left and down 3. And now when I'm done, I'm moving it 1 right and up 3 in order to get back to where I was before. So in my work here, I can go back, to the true origin, by doing the opposite of this shift, right 1 and up 3. And the final coordinates of this image is going to be, let's see, 2, 5. And I'm just adding 1 to all the top row. So 2, 8, 0. And then 5, 3, and -1. Adding 3 to all the ones on the bottom here. And this gives me my final image, which is A prime, B prime, C prime. And let's see if this matches. So 2, 5 should be the coordinate of A prime. 1, 2, 1, 2, 3, 4, 5. B prime should be 8, 3. 1, 2, 3, 4, 5, 6, 7, 8, up 3. And then C prime should be at 0. No, I'm sorry, it shouldn't be at 0. It should be at -1, -1. Okay, I made a mistake here. So -2 plus 1 is -1. And -4 plus 3 is -1. So should be at -1, -1. Okay, and there you have it. Now I'm going to connect all these big purple dots here. Okay. And so what this goes, hopefully one of the things that we can take away from this is that the XY coordinate plane is just a tool for us to manipulate. It's not the purpose of the work itself. It's just a tool for us to manipulate to help us do the work better in a more effective way. We're not married to it by any ways. We certainly don't have to stick to it all the time. So hopefully you are able to extract what you can from the process of this. As always, keep working hard, and if you have a question, please ask your teacher. Thank you for watching, and have a wonderful day.